Hello students, in this session we will discuss about various electrical machines and their uses. By the end of this unit, you will be able to know about different electrical components, know about different electrical machines and their uses. Understanding of electrical components. Cables. Electric power is transmitted or distributed either by overhead cables or by underground cables. Classification of cables. Low tension cable up to 1000 volts. High tension cable up to 11,000 volts. Super tension cable up to 33 kV. Extra high tension cables 3 kV to 66 kV. Cable carrier and support. The systems used to carry, support and run the wires are called cable carriers and support system. Different systems are adapted for this purpose. Switching and terminating products. The major terminating and switching products are switches, sockets, sealing roses, holders and adapters. Cutouts. In electrical distribution, a fuse cutout is a grouping of switch and fuse which can be utilized in main overhead lines and protects distribution transformers from electric surge and overload. Now let us discuss the difference between alternating current and direct current. Alternating current. The flow of electrons switches back and forth at regular intervals called cycles or frequency. Example, 50 cycles per second in India. AC current is obtained from alternators. Household wiring, majority electrical equipments in industry are run on AC current. AC current can be converted to DC current by rectifier. AC current is safer than DC current on electrocution. Direct current. The flow of electrons in one direction only having cycle or frequency equals to 0. DC current is obtained from generators, batteries, solar cells, etc. Digital electronic equipment, vehicles and highly controlled precision industrial equipment are run on DC current. DC can be converted to AC by inverter. DC current is more dangerous than AC current on electrocution. Understanding of electrical machines. A fitter electrical assembly technician has to deal with many electrical machines. In this section, we will know about some of the standard electric machines. Electric motor or DC motor. An electric motor is an electromechanical machine that converts the electrical energy into mechanical energy. It works on the principle of Lorentz law, which states the current carrying conductor placed in a magnetic field experience a force. This force is called Lorentz force. When an energized rectangular coil is placed in a magnetic field, a torque is generated which continuously rotates the coil. When the coil rotates, the shaft attached to it also rotates and do the mechanical work. Parts of an electric motor. Armature. An electric motor consists of an insulated copper wire rectangular coil wound on a soft iron core and forms the armature. Commutator. A commutator reverses the direction of flow of current. Commutator is made of a copper ring which is split into two parts, insulated from each other by mica. Brushes. The brushes are made with carbon or graphite, making sliding contact over the rotating commutator. The brushes are used to relay the current from external circuit to the rotating commutators, from where it flows to the armature windings. Working of a DC motor. Step 1. When power is supplied to the coil, a magnetic field starts generating in the region of the armature. The left side of the armature starts moving away from the left magnet and drawn towards the right. This starts the rotation of the coil. Step 2. The coil turns at an angle of 90 degree and then the brushes loses contact with the commutator. When contact between the brush and commutator loose, current stops flowing through the coil, but due to its momentum, the coil keeps turning. Step 3. The coil turns 180 degree and the slides of the brushes are interchanged. Commutator ring C1 is now in contact with brush B2 and commutator ring C2 is in contact with brush B1. So the current keeps flowing in a similar direction. Electric generators. An electric generator converts mechanical work into electrical energy. Parts of an electric generator. Yoke of DC generator is made of cast iron. It holds the magnetic pole cores of the generator and acts as a cover for the generator. Poles of the generator. The pole coil are wound around the pole core. These are a simple coil of insulated copper wire which is placed over the pole. Armature of DC generator. Armature core carries armature windings and provide low reluctance path to the magnetic flux. Commutator. It collects current coming from the armature and passes to the load in form of direct current. Brushes of the generator. The brushes are made of carbon and are rectangular. They collect current from the commutator segments. Working of a DC generator. An electric generator works on the principle of electromagnetic induction phenomenon. According to it, whenever a coil is rotated between the poles of a magnet, an induced current is set up in the coil. Moving a conductor in the magnetic field produces a voltage difference between the two ends of the wire, electrical conductor, thus providing an induced current. Pumps. A pump moves or sucks fluid, whether liquid or gas, by some mechanical action. Pumps perform mechanical work in form of moving fluid when started by an electric power. Basic types of pumps. Vacuum pumps. Vacuum pumps expels the gas from a sealed volume of gas, leaving partial vacuum behind. Water pump. They pump water from the ground and used in pressure tanks within the location. Thrash pump. Thrash pumps are used to pump wastewater. Hydraulic pumps. These pumps are utilized in hydraulic drive systems. Compressors. A compressor is a mechanical device that increases the pressure of a gas by reducing its volume. Compressors are of two types. Gas compressor is a device used to pressurize fluids. Air compressor is a device used for compressing air to give power to other tools. Gas compressor. Compressors are similar to pumps. They increase the pressure of the fluid and move the fluid through a pipe. Compressors also reduces the volume of the gas, which is compressible in nature. Gas compressors are used in various applications where either high pressure or low volume of gas are required. An air compressor converts electric power into potential energy stored in pressurized air. It forces maximum air into a storage tank and this increases the pressure. When the pressure of the tank attains its upper limit, then it stops working. The energy of the compressed air is used in various applications. After utilization, depressurize the tank and when pressure reaches its lower limit, the air compressor starts again and repressurizes the tank. EOT cranes. Electric overhead traveling cranes or EOT crane is one of the most common types of overhead cranes or called bridge cranes. It consists of parallel runways with a travelling bridge spanning the gap. Operation of crane. Before operation, check whether all parts are lubricated properly and electrical wiring is done according to the electrical wiring diagram. Check the limit switches are cutting off the motor supply in appropriate direction. If they are not cutting off the supply, make the necessary changes in the wiring. Commence lifting the load in stages. Start it with a load which is not more than 5% of the safe working load, and then increase the load in gaps for safe working until you have reached the full load. Do not load beyond the rated capacity. Overloading can cause the defects and make failure in future. Applications. In steel plant, pouring of raw material into furnace is done by crane. After metalworking process, material is moved by an overhead crane for cooling. Lifts the finished coils into trucks and trains by overhead cranes. The session ends here. Let us have a quick recap before we proceed to the next topic. Electric power is transmitted or distributed either by overhead cables or by underground cables. The major terminating and switching products are switches, sockets, sealing roses, holders and adapters. Electric motor is the electromechanical machine that converts the electrical energy into mechanical energy. An electrical generator converts mechanical work into electrical energy using electromagnetic induction. A compressor is a mechanical device that increases the pressure of a gas by reducing its volume. Electric overhead travel crane or EOT crane is one of the most commonly used types of overhead cranes.